Hey everyone, today we're going to be talking about volumes of revolution. This time, instead of just one function, we're going to be using two. So here is the general rule for finding the volume of revolution. We talked about this last time, where volume is equal to pi, the integral from a to b of the function squared. So now we're saying if I have two functions, what I actually care about, similar to area, is which function is on top and which function is on the bottom. We call the top function f of x and the bottom function g of x. When we now take those two functions and we rotate them about the x-axis, we get this donut-shaped product. So basically, what we come up with is the formula to calculate the volume between two functions or two curves. So that's the volume is equal to pi from a to b of the top function squared minus the bottom function squared. So notice that each function is squared on its own and then we're subtracting. So we're going to try a couple of questions here. I encourage you before you play the video to pause it, draw the functions, and then try and figure out what the volume is according to the formula. Once you have the diagram, so once you figure out which function is on top and which function is on bottom, the question in and of itself becomes very straightforward. So give it a shot. Okay, so here in the first question, it says find the volume of revolution generated by revolving the region between y is equal to x squared, so a general parabola, and y is equal to square root of x, so a general square root function. So step number one is to graph. I encourage you to double the scale so it's a little bit bigger and you can see everything. Okay, so here I have drawn my parabola here in red, and I've drawn my square root function here in blue. And so the area that I'm trying to find is the area here in black between the two functions. Notice that my top function is root of x and my bottom function is x squared. So now I simply have to figure out where they intersect. Now, remember that if I'm at a point where my graph or my diagram is horribly drawn and I can't see from my diagram that it intersects at 0, 0, and 1, 1, then I can set the two functions equal to one another and solve for x. So when I do this and I set the two together, I square both sides and I get x is equal to x to the 4. I bring everything over, set it equal to 0. I factor and I get x is equal to 0 and x is equal to 1. So again, if my graph isn't that great and I can't see visibly exactly where they intersect, then I can set them equal to one another and solve. So now I want to set up my integral. When I set up my integral, I get the volume is equal to the integral from 0 to 1 of root x squared, all squared, minus x squared, all squared. The one thing that people often forget at this point in time is that they forget that they need a pi symbol right at the beginning. So often two mistakes are that there's a pi here at the front, or people forget to square the functions. In doing so, that causes a problem. So please remember, make sure that there's a pi in the front there and make sure each function is squared. Now, next step. I simplify, so I apply the squareds. I get the pi 0 to 1 of x minus x to the 4. I want to integrate and substitute in. So when I integrate, I get x squared over 2 minus x to the 5 over 5. I'm applying that from 1 to 0, and I'm multiplying that by pi. When I do so, my final answer is 3 pi over 10, and you can write units cubed. This here, very straightforward. Let's say I wanted to do this in my calculator. So at this point in time, I remember that I can't put in two separate functions into the calculator, so I'm going to put, notice here I'm using blue, so I'm going to put this here into y1. I'm going to graph this, and I'm then going to go second trace number 7, which is the integrate button, and I'm going to integrate from 0 to 1. I will get 3 over 10 as an answer. You'll actually get 0.3, and then remember to multiply by pi. So very simple and very straightforward. Okay, so the next question says, find the volume of the solid formed by revolving the region enclosed by the following curve and the line g of x equals 3 about the x-axis. Well, the first question you need to ask yourself is, what is f of x? What is this function? Hopefully you recall from last class that that's the top half of a circle with a radius of 5. So you're going to want to draw the top half of a circle and then g of x is equal to 3. So give that a try. So I've drawn the circle with a radius of 5. I've doubled my scale here a little bit, and I've got it in red. And I've got the line here, g of x equals 3 in blue. The area that I'm trying to find is the one enclosed, so right here. And so in black. And I notice again that this is lovely and symmetrical, so I'm going to use that to my favor. And let's say hypothetically again, I didn't draw a perfect diagram and I don't know where they intersect. I'm going to figure that out. So first things first, I'm going to figure out where f of x is equal to g of x. So when I set the two functions equal to one another, I get that x is equal to plus or minus 4. Well, that's awesome. That means that it meets here at -4 and here at 4. Now, because I'm really smart and I know that a circle is symmetrical and that this side of the area from here to here is the same as the other area from here to here, I'm going to use that to my advantage. So from here to here, it's the same as from here to here. So when I write my volume, I'm going to double the volume from 0 to 4. So notice here I've written 2 pi instead of pi, and notice my integral is from 0 to 4. My top function is the circle, so the red function, and my bottom function here is the blue function. So again, I've written the top function here, squared, minus the bottom function squared, so I'm remembering to square, and now I simply apply the squared and I get 25 minus x squared minus 9. I'm going to collect like terms, which will make my life a lot easier here. So when I do that, I get 16 minus x squared. I'm going to integrate one more time and apply it from 0 to 4. So here's my integral. I'm going to sub in 4, and when I sub in 0, everything cancels out. So this is what I get, and my final answer then is 256 pi over 3 units cubed. So in and of itself, finding the volumes of revolution between two functions is not that difficult. It's not that challenging. But I do want you to remember two things. One, don't forget the pi. And second, don't forget to square each function individually. When you do that, the question becomes very simple and very straightforward. So give the practice a try. If you have any questions, come and see me.